Okay, so we are continuing next part of probability, which would be multi-stage events, right? We did this one, relative frequency, multi-stage events. I remember when I was teaching it to you girls, you did have a bit of issues with this, only because of the difference between or and the fact that when you're meant to actually add compared to when you're meant to multiply. So I'll write it up again. It is a little bit helpful for certain questions, and other questions you've got to actually understand how it's working. But if you've got an and question, you're multiplying. If you've got an or question, you're going to be plussing. So that means if I said, what is the probability of having a boy and a girl? That means you're going to do half times a half. Whereas if I said, what's the probability of having a boy or a girl? You would say that's a half plus a half, which is 1. So that does make sense. If you're having a boy or a girl, well, you definitely will have a boy or a girl. It can't be anything else. That's the only two genders. So that's 100%. Whereas if you said boy and a girl, that means you specifically need to have a boy and a girl, right? So that's 2 kids, and it's got to be like that. And then that answer becomes a quarter. So the difference in and or is really important, but it's also really important to understand the different cases. So the cases do get a little bit complicated at times. I think we're going to do, just like we did in finance, most of these questions we'll probably do, we'll do each one, because each question does change and the thinking changes a little bit. It's not like algebra where you just learn the one thing and it's just, repeated. So let's start. Multi-stage events. Question 1. There's 1 red, 1 blue, and 1 white ball. They're in a box. The balls are removed one at a time and placed in a row. List all the possible outcomes. Well, okay, of course, you could have had a red, a blue, and then a white. You could have had a red, a white, and a blue. You could have had a white, blue, and a red. You could have had a white, red, and a blue. You could have had a blue, red, and white, and then of course a blue, white, and a red. And see how I did them in order, I guess. A lot of students I see just go, oh yeah, red, blue, white, and then they'll go, oh, white, blue, red. Now blue, red, white. There's no consistency. So the way I did it is I finished off all my reds. Yep, done. Then I did all my whites first. Done.
Would you lose a mark if you did it not in order?
Say that again.
Would you lose a mark if you
no way. But the problem is, if you don't do them in order, you might miss a case.
Okay.
All right. So what I've usually seen is, like, let's just say for our, I don't know, let's say if I had 4 coins and we're going to go tail, 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 and then some students go, oh, okay, next one's head, 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 head. I'm like, yep. Right. And then what? They're like, oh, head, 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 tail. I'm like, yep. And then like, oh, I don't know, tail, head, 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 and then like there's no consistency. You'll forget what you started with and what you're meant to go to start with. So if it was that particular question, this is the way I would have attempted it. I would have said, okay, imagine there were all tails. Beautiful. Now the last one I'm just going to change. So tail, 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 head, and that's it. There's no other cases I can do. Now I'm going to change the second one instead of the last one. So it'll work like this: tail, tail, head, tail. And that's it. Then I'm going to change the third one. That'll be tail, head. Then I'll do tail, tail. Then I'll go tail, head, tail, head. See, I'm still keeping that third one there. Tail, head, and then again head, tail. Keep the third one there. Tail, head, head, head. Keeping these two, the first 2 constant. And I'm just changing the last 2. And then if I had to change the first one, I know that the first one's just going to become heads now, so I'll just repeat all this. Instead of T, 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 it'll be H, 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 H.
Yeah.
T, 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 H. So I can just go, okay, how many is this? 1, 2, 3, 4, 5, 6, 7. I must have missed one. T, 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 H. See, I've missed one. How bad is that? T, T, H, T. T, T, H, H. I didn't do that. So look at that. T, 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 H, T, T, H, T. before I moved here, I should have had a TTHH, which I don't have.
Okay.
Really bad of me. There you go. And that shows you right there. If you don't do things in order, you will miss one. And I tried to even do it in order, and I almost missed one.
Sam, with probability,
Yeah.
is a good way to just remember it that the amount of the amount of options or possibilities is just double.
For your second case?
Yeah, so for example, we had like the 3 balls, there were 6 different options, or for this one we had like 4, the coin was done 4 times, there's 8 options for each. Was it just doubled or?
Good point. Give me a second. Oh, God. But that only works because of the fact that there's 1. What if there was 2 reds? Would it still be like this? It'll be 4 times 3 times 2 times 1. Technically, it's I'm very hesitant to give you a one-way out because probability is very complicated, but technically it's like this. If there's 3 options, 1, 2, 3, so let's say 1, 2, 3 spots, the idea is you've got to think about how many different colors can I pick from that can go into the first slot. And you would say, okay, well, that would be 3 colors. Now imagine you've chosen 1. How many colors do I have left in the second slot? That would be 2. And then again, you've chosen 1 from here now. How many is left? There'll only be 1 left. And the idea is this is the exact number of combinations you'll have. 3 times 2 times 1, which is 6. So in this case, it's a bit complicated, but it's not like that. It's just, look, it can't be like that because there's some repetitions and stuff. It's trickier than what you just said. That's all I can say right now. We will be going through all the different cases of questions, and you'll start to understand when order matters. So something like these, and when what you're going to be doing compared to when order doesn't matter. So it's not necessarily like what you just said. It was just by pure coincidence that it worked out these 2. Okay. Good eye good eye for seeing that, but I can't say it works all the time. So no. How many different possibilities are there for the first ball? Well, obviously there are 3 different possibilities for the first ball. It's either red, white, or blue. So 3. Once the first ball has been chosen, how many possibilities are there for the second ball? Oh, look, I think they're making you do what I just showed you. 2. Of course, once the first 2 balls have been chosen, how many possibilities are there for the last ball? 1. Any questions about that? No. The numbers 1, 2, 3, 4 are written on 4 cards, 1 on each card. The cards are shuffled and then placed side by side to form a 4-digit number. List all the possible outcomes. Again, we'll go 1, 2, 3, 4, 1, 2, 4, 3, 1, 3, 2, 4, 1, 3, 4, 2, 1, 4, 2, 3, 1, 4, 3, 2. Yes. And then that's all the numbers that you can start with, that you can get by starting with 1. Right? That's all the numbers that you can get by starting with 1. Obviously, if you have to start with 2, 3s, and 4s, there's going to be different combinations of these. So without me listing them, I'm sure you guys can do that. But the idea is how many outcomes are possible now. You'll know there's 1, 2, 3, 4, 5, 6 times by 4 different numbers to start with. You guys get that? What I mean by that?
Yeah.
Yeah. Another way to see it is this circle way, and I think this is the way I personally teach the extension kids. we just draw them out. So like imagine you got 4 cards, you got 4 slots, 1, 2, 3, 4, 4 spaces, whatever. 4-digit number, 1, 2, 3, 4. How many numbers can you pick from that can go in the first digit? How many numbers can you now pick from? And now, times. What's 4 times 3? 12, 12 times 2, 24. So that also gives you the amount of combinations that are possible. All right?
Yeah.
So, Kara, I think, see, you were saying like, oh, can you just double it and stuff? See how it doesn't work all the time? See here, these numbers are all different. 1, 2, 3, 4. Whereas in this case, T is the same as T. So you can't really change it at all. You can't really change their positions because they're the same T's. Whereas here, there's still four let's call them 4 different T's, but at least they're different. They're not the same T's. This is T1, T2, T3, T4. So obviously there's more combinations, more possibilities of this than the other one up there. So yeah. If a 5th card with the number 5 on it is added and the 5 cards are now shuffled and placed side by side, how many different 5-digit numbers are possible? Well, I think you guys get the idea. You're just going to put a 5 in front of it, right? So it would work like this: 3, 4, 5. There will be how many numbers? If there was 5 digits, how many numbers can you pick from? And then once you pick that, how many numbers left? How many numbers left? And so on. So it'll be pretty much 5 times 4 times 3, so 5 times 24. What's that, 120? Any questions?
Nope.
I've done that well. Let's have a read of this. The letters A, B, and C are written on 3 cards, 1 on each card. The cards are shuffled, 1 card is selected, the letter is written on a whiteboard, and then the card is replaced. The cards are reshuffled and another card chosen. What does that mean? Firstly, what's happening here compared to what wasn't happening here?
That like the card's getting put back.
Yeah, the card's being put back. So you can technically get, let's say if there was 3 of them, you could get AAA because being replaced. But we'll continue reading. It's getting replaced. The cards are reshuffled and another card chosen. The second letter being written beside the first and the card replaced. Again, the cards are reshuffled and a third card is drawn and the third letter is written on the whiteboard beside the other 2. There's all the possible outcomes. So you obviously can get AAA this time. You could get AAB, you could get AAC, and that's here with A8. Then you could get ABA, you could get ABC. You could even get ABB. You could even get that's it with B's, right, as your second column. Yep. You could get ACA, you could get ACB, you can get ACC. See how I'm trying to keep the first one always the same?
Mm-hmm.
And then I'm finished with all the A's, right, because the second column was A's, and then the second column here was B, and the second column here was C. So I finished with all of the possible outcomes of them changing. Then now the first column could change. So instead of it being A, it could have been BBB, BBA, BBC, and so on and so on and so on. So you're just going to times all of those number of combinations by 3. A, B, C. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 3, 27. Because there's repetition, this is how you would draw it if you want to do it my way here. Watch this. How many numbers or how many letters can I pick from that can go here? Come on, give me an answer. How many letters can you pick from that can go here?
ABC.
Yep, so how many letters is that?
3.
Okay, cool. Now it's being replaced. So how many letters can I pick from that can go here?
3.
How many letters can I pick from that can go here?
3.
3 times 3 times 3
18.
equals 27.
Jokes.
3 times 3 is 9. 9 times 3 is 27.
I think it was 18.
Yeah, because you're thinking of 3 times
No,
3
that's
is
6.
6, and 6 times 3 is 18, maybe. Yeah, that's all right. 27. So you can see you can either do it this way, the possible outcomes way, or you can learn it, you know, I guess the more professional way, which would be this. And you can assume the top students in your course would obviously understand it this way. So it'll be really good if you can understand the way I'm showing you. Okay, if a fourth card was selected, in the same way, how many total possible outcomes are there? Easy, right? 1, 2, 3, 4. That would be 3, 3, 3, 3, 3, 3. So essentially it would be 3 to the power of 4. What's that? 81, I think. Yes, it is. If 8 selections were made, how many? 6,561. All right. Any questions?
Nope.
Nope. Happy, 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 happy. Good. Very, very good. Killed that. All right. Two-way table. Let's learn how to read these. Question 1. Jack surveyed the type of cars in a shopping centre car park and recorded the results in the table. Of course, these are the vehicles, and this is the transmission, if it's a manual vehicle or if it's an automatic vehicle. And then, of course, if you had to, create another column here just so you guys can see something. Boom, boom. All right. If I create another cell here, 16 plus 14 gives me 30 manual cars. 34 plus 36 gives me 70 automatic cars. That's 100 cars altogether. If I've done it right, 16 plus 34, that's 50 sedans, and obviously 14 plus 36, that's also 50 SUVs. 50 plus 50 is also 100. And that's how two-way tables work. Right?
Mm-hmm.
Now, it is really important with two-way tables to just read carefully, because there's a time when you're just going to write 34 out of 50 compared to 34 out of 70 compared to 34 out of 100. And that's where obviously the confusion is with two-way tables. Students just don't get that. So just be aware of it. I've already told you in advance. There's going to be a time where you've got to write the answer as 34 out of 50. There'll be a time to write 34 out of 70, and there'll be a time to write 34 out of 100. It just depends. If you wanted a 34 out of 50, therefore you wanted to know how many automatic sedans there are out of the sedan cars. So if I'm picking a sedan, how many of them are automatic? That would be 34 out of 50. Or if I was to pick a car that's automatic, how many of them are sedans? That would be 34 out of 70. See the difference there? I want to pick up a sedan. How many of them are automatic? You would say, okay, sedans, there's 50 of them, and then 34 out of 50, compared to I want to pick up an automatic. So you would say, okay, there's 70 automatic cars. How many of them are sedans? You would say 34 out of 70. And then if I said, I'll just go randomly into a car yard, let's say, or a shopping center, whatever, shopping center car park, and I want to work out how many automatic sedans there are. Well, that would be 34 out of 100. Yeah, so you got to just know that there are going to be 3 different cases. Being aware of it is usually step 1. Once you're aware of it, most of my students are just go, yep, I already realized, okay, this question's going to be these or whatever. Just be aware of it. That's it. That's what you need to know for now. A, what was the total number of vehicles surveyed? We've already worked it out, 100. Okay, how many vehicles were automatics? How many vehicles were automatics? Again, we've already worked this out, 70. If a vehicle was chosen at random, what is the probability that it is a manual sedan? It's just chosen at random for it to be a manual sedan, then it's just going to be 16 out of 100. For it to be an automatic, it would be 70 out of 100. Not an automatic, that means obviously a manual. Or you can do what we learned last week, 1 minus 70 out of 100 for not an automatic, so 1 minus an automatic. Or, obviously, you know it's just 30 over 100. And obviously these simplify, but okay. Maybe that's right instead of all there, which equals to that. If an automatic was chosen, see there? Look at that question. Read that compared to C. If a vehicle was chosen, okay. If an automatic was chosen, so how many automatics do you have?
70.
70. And then obviously, what is the probability it was an SUV?
36.
Like that. Not an SUV.
34.
So important. If an automatic was chosen, that means you're looking at 70s. All right. Cool. I feel like you guys can do that one. Let's try maybe this weird looking one. Let's say question 3. Emma places 3 red balls. Emma places 3 red balls and 2 blue balls in a bag. The red balls are numbered R1, R2, R3, and then blue balls are numbered B1, B2. The 2 balls are to be chosen at random from the bag. She has started to fill in the table with all the possible outcomes. So of course, fill in the remainder of the table. R1, R2, R1, R3. We get it.
Yeah.
R1, B1, blah, blah, blah. All right, I'm not going to continue that. We get that. Okay, how many outcomes are possible? 1, 2, 3, 4, 5, 6,
25.
7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20, not 25, because you can't get it. You can't get an R1 and an R1. Emma places 3 red. There's only 3 red balls, and then the red balls are numbered R1, R2, R3. So you can't really get an red one and another red one.
Okay.
Unless there was 2 red ones, or unless there was 2 red ones, which there isn't, or if they said they were replaced. Which it doesn't say that either, so you can't. That's why they've got the dashes there. So yeah, just 20. What is the probability of selecting R2 and B2 in any order? So which means R2, B2 or B2, R2. R2, B2, 1. B2, R2, there you go, 2. So it's obviously 2 out of 20. What is the probability that both balls are red? Well, that would be 1, 2, 3, 4, 5, 6. So I think that's 6 out of 20. And then, of course, what's the probability that it's numbered a 2? Well, that would be 1, 2, and then what did I say? Sorry, 1, 2, 3, 4, 5, 6, 7, 8 out of 20. Any questions there?
No.
No.
All right. Question 4. Make sure. Sorry, is the connection just getting worse right now?
Yeah.
Yeah, you're breaking up a lot.
Yeah, it's because I'm getting a call. So what happens is I'm on my mobile hotspot, so I'm trying to ignore it, but they keep calling. A group of Year 11 students were surveyed. The students were asked whether they live in a city and whether they have their L plates. The results are detailed in the table. How many students were surveyed? Well, 32 plus 48, 70, 80, 18 plus 12, I think that's 30, so that becomes 110, 50, 60, and that should be 50. Okay. How many students were surveyed? We said 110. How many students live in a city? 80.
80.
How many have L plates? 50. A person is selected at random. What is the probability that they live in the city? They live in the city, but do not have L plates. They live in the city, but do not have
48.
48 out of
80.
80 out of 110.
Oh.
Yes.
But isn't it ask?
They live in the city, but do not have L plates. But maybe you're right. Hold on. Why do I say first select at random? What if they live in the city but do not have? So they live in the city but do not have L plates. It's 48 out of randomly out of all of them. No.
Oh, okay.
It's out of 110. It's a random selection.
Okay.
This bit here, what is where they live in the city, is just trying to tell you, look at this column. Oh, sorry, look at this row, and then do not have L plates. Means look at this column, and obviously where do they meet? They meet there. That's all.
Okay.
But here, a person who does not live in the city is chosen at random. See? Person who does not live in the city, so they already know it's one of these 30 people. What is the probability that this person has L plates? This person, that out of the 30 people, has L plates. Well, now that becomes 18 out of 30.
Okay.
So there is a difference between a person that does not live in the city is chosen at random. They've already chosen a person who doesn't live in the city. They know that for fact. They know it's one of these 30 people. Then, out of those 30 people,
Sally, can you hear him?
No. I'm confused.
Yeah.
My head hurts.
My ponytail, like,
Yeah, I just took it out and it really hurts.